Hey guys, it's Miss Johnson and I'm here to bring you our third notes video for Unit 2. Today we're solving systems using substitution. So our first 2 days we're talking about solving with graphing. We were graphing equations and graphing inequalities. Now we're getting into algebraic solving. And the first method of algebraic solving that we're going to see is called substitution. So here are our steps for substitution. Now I'm going to reveal the steps for you. I want you to pause your video for a minute and write them down, and then I'll talk you through them. So step number 1 is when we solve one of the equations for one of the variables, we need to get one variable alone. Now, typically speaking, we used to always want to get y by itself so that we can graph. It doesn't matter with substitution which variable you start with. It could be y, it could be x. It doesn't matter. We just need one variable alone in one of the equations. That's where the substitution part comes into play. We're going to substitute the expression that it's equal to back into the other equation. So then the next thing is we'll just solve for the variable that's left, because at that point only one variable will be left. Then we'll do another set of substitution and put that back in. Okay, so these are kind of the steps that we're going to go through. They might not make a lot of sense now, but we'll do a bunch of examples to see what they look like. Now, most of the time we're going to get one solution. We're going to get a point, an intersecting point, like we did when we were graphing systems. We'd have a point of intersection, and that point was our solution. But it is possible, as we saw with graphing, to have something like infinitely many solutions and no solutions. Now, infinitely many solutions were lines that ended up being one right over the top of each other. No solutions were lines that were parallel and never crossing. Okay, now here's what that looks like algebraically. If we have infinitely many solutions, what happens is both of our variables will cancel out, will drop out of the system, and we'll be left with a true statement, meaning like 0 equals 0 or 5 equals 5. Okay, some sort of statement that is true. On the flip side of that, if both variables drop out and we're left with a false statement like 0 equals 6, that's not true. That doesn't exist. That can't be possible. That's where we have no solution. So when both variables cancel, it's either going to be true, which is infinitely many, or it's going to be false, which is no solution. So again, you can pause your video and take a second to write those two down if you need to. Let's take a look at number 1, our first system. So I have x plus 2y is equal to 8, and then I have x is equal to 2y plus 36. So the first thing I want to look for, the first thing my eye is drawn towards is the fact that this x is by itself. It says x equals. So what happens is this phrase that it's equal to is going to replace x, or in other words, be substituted for x on the other side of the equal sign. So what that looks like is I'll have 2y plus 36 in place of that x. But I still have the rest of the equation. So plus another 2y is equal to 8. So I took this phrase that was equal to x and I plugged it in for x in the top. Okay. Now I solve for y. I have one equation with one variable. I can solve that. So my y terms are going to go together. I have 2y and 2y, which is 4y plus 36 is equal to 8. And then I subtract the 36, and I have 4y is equal to negative 28. And then divide by 4, and I have y is equal to negative 7. All right, so I've got one of my variables, but that's not enough. I have to get them both. So now I'm going to take the y variable that I know, and I'm going to plug it back into one of my original equations. I'm just going to use this bottom one because I already have x alone, which will help me. So I have x is equal to 2 times negative 7 plus 36. That's x equals negative 14 plus 36, and that's x equals 22. So now when I write this out as a solution, I write it as an ordered pair. My x value is 22, my y value is negative 7, and that is my solution to the system. Okay, let's try that again in number 2. So in number 2, I don't see any variable that's by itself yet, but I do see one that I can easily get by itself. In this bottom equation here, this x doesn't have anything larger than, the x coefficient is 1. That's what's helpful to me, the fact that the x coefficient is 1 here. So all I need to do is subtract 2y and move it over. So that gives me x equals negative 2y plus 15. All right, so now here's my x phrase. This phrase is equal to x. So I'm going to take this phrase and I'm going to drop it right there in for my x variable. The 2 stays. All I'm taking out is the x. That's the only thing I'm substituting. So the 2 that was already there stays. I'm going to put this guy in parentheses. So negative 2y plus 15 in parentheses. Minus 3y is equal to 2. And again, now I solve for y. So when I solve for y, I distribute this 2. That's negative 4y plus 30 minus 3y is equal to 2. I can put my y terms together. Negative 4 and negative 3 is negative 7y plus 30 is equal to 2. And then subtract the 30. Negative 7y is equal to negative 28. And then divide by the negative 7. So I'm left with y is equal to positive 4. Then I need to go back and substitute that in to get my x variable. It does not matter which equation you pick. I'm just going to pick this top one. I'll have I'm going to pick the bottom one. X plus 2 times 4 equals 15. That's x plus 8 equals 15. Subtract the 8. That's x equals 7. So then my solution when I write it out is 7 comma 4. All right, let's try the next one. So in the next one, I again don't have a variable that's by itself already, but I do have a variable that has 1 for a coefficient, this x right here. So I'm going to add 3y to the other side so that I can use that equation. So I have x is equal to 3y plus 0, which is just 3y. So now x is by itself. Here's the phrase that I'm going to use that for x in place of x in the other equation. So that's the substitution part. I'm going to take this phrase and I'm going to substitute it in for x. So it's going to go right there. Get rid of the x, put 3y in its spot. So when I rewrite that top equation, it looks like this. 7y is equal to 26 plus 11 times 3y. So I have 7y is equal to 26, multiply those together, plus 33y. I'm going to move my 33y over here since there's nothing else on that side. So minus 33y, minus 33y, and I get negative 26y is equal to 26, and divide by negative 26. So y is equal to negative 1. Then I need to plug it back in to get the y variable. I'll just use that bottom equation again. I'm sorry, I need the x variable. I have y. I'll use the bottom equation. So I have x plus 3 times negative 1, which is what I just solved, is equal to 0. Ooh, and I wrote that wrong. It should be x minus. Oops. Sorry about that. X minus 3 times negative 1. I think my brain was already putting those together because negative 3 times negative 1 is positive 3. So that's x plus 3 is equal to 0. Subtract the 3, and you get x equals negative 3. So your solution to the system here is negative 3, negative 1. All right, let's take a look at number 4. So in number 4, I have 2 lines that say y equals, which is helpful because I have y alone in a couple of spots. So it doesn't matter which one you substitute, you just need to take one of the phrases and put it in for the other y. So if I think of this y being equal to that phrase, I'm going to take that phrase and plug it in for y in the other equation. So I get rid of y. I plug in 3x minus 4 in its spot, and then I finish out the rest of the equation is equal to 4 plus x. And now solving that, subtract the x from both sides. That gives me 2x minus 4 is equal to 4. Add 4 to both sides, and I get 2x is equal to 8. And divide by 2, I get x equals 4. Plugging that in to get the other part of the equation, I'll just use the top equation, or the other part of the solution. Y is equal to 3 times 4 minus 4. That's y is equal to 12 minus 4, or y is equal to 8. So my solution to this system is the point at 4, 8. All right, let's flip it over to the back, try a couple more. Use substitution in number 5. Now, the top equation in number 5 has two variables that both have coefficients that are not 1, and they're together on the same side. The bottom equation has x on one side, y on the other. They both have a coefficient that's not 1, but at least this x is already alone on one side. So the only thing I would have to do for the bottom equation to have a variable alone is divide by 2. So that's what I'm going to do. I'm going to start by dividing the bottom equation by 2 because what that does is give me x by itself. Oops, that's not a 4 anymore. That's now going to be a 2. So that's what I have. I have x is equal to 2y plus 2. Now I can take this, which is equal to x, and I can plug it in right there. So I have 3 times, put this whole thing in parentheses so you remember to distribute, 2y plus 2 minus the 6y is equal to 6. I got rid of that x, put the phrase that it's equal to in its spot. Now I solve for y. Distribute, that's 6y plus 6 minus 6y is equal to 6. A lot of 6's going on there. What happens here is 6y minus 6y goes away, and I'm left with 6 equals 6. Now, check it out. No variables left. This is one of those instances where our variables dropped out. So then you have to take a look at what's left and ask yourself, is it true or is it false? Well, 6 does in fact equal 6. That's a true statement. So what this means is this is an infinitely many solution system. Number 6, I look for a variable that's by itself, and I don't see one that's alone, but I do see one that has 1 for a coefficient. So that's what I'm going to work with. I'm going to subtract the 7 from both sides so that I have y equals, sorry, that's ugly to look at, y equals 2x minus 7 for that phrase that I'm going to solve. Then I take this piece that's equal to y, and I plug it in for y right there. So get rid of that y, keep the 3, but get rid of the y. I have 6x minus 3 times that whole phrase in parentheses, 2x minus 7 is equal to 24. Now I have all x's, and I'm going to distribute and solve. 6x minus 6x minus 20, oh sorry, plus 21 is equal to 24. Negative times negative, so positive 21. 6x minus 6x, again, goes away. So again, I'm left with no variables. Now I have 21 is equal to 24. And you ask yourself, is that true or false? Well, this one is false. 21 does not equal 24. So this is a system that has no solutions. All right, so now let's take a look at some word problems. I'm actually going to pause your video or stop your video at this point, and you can go ahead and work on part of your practice if you'd like. You can show Ms. Johnson your front half of your worksheet, and you can start working on your front half of your note sheet and start working on your practice, and then I'll come back in a separate video and finish the last 4 questions.